I suggest at this point you pause the video and you look at this picture really well, because it's really important and it's going to be referenced a lot throughout the course. Here we have a traditional Cartesian coordinate system where, as usual, this is the x-axis and this is the y-axis. There's a circle with center at the origin that has a radius of 1, and this circle we call the unit circle, and we intersect it with the axis at these 4 points. Now I'm going to introduce the concepts of a directed length and directed angle. Directed length just means usual length but with a sign. For example, suppose I take a segment onto the x-axis such that one of its endpoints is at the origin. Then if the other endpoint points somewhere in this direction, then I'm going to call the length of the segment positive. The directed length is going to be positive. For example, if I take the second point here at 2, the segment is going to have a length of positive 2, because this is the positive direction. Conversely, if I put the second endpoint here at negative 2, then the directed length of this segment is going to be negative 2, because it points in the negative direction. On the y-axis, we can do the same thing. We can assume that all lengths right here on this side are positive, and all lengths on this side are negative. Now, what is a directed angle? As with segments, one of the endpoints we put at 0. With angles, we're going to put one of the rays at the 0 angle direction, which is this direction here. So the positive x-axis direction we call the 0 angle direction. Here, we put the first ray, and if we put the second ray on top of it, here, then the angle between the two rays is 0 degrees. Now, we can start rotating the second ray around the unit circle, and thus we can associate a point to every angle that we make with the 0 degree direction. For example, if this is our second ray, it makes a 90 degrees angle with the 0 degree direction, with the 0 degree ray, with the first ray. So this angle is 90 degrees. Therefore, we can associate this point here to this 90 degree angle. You can imagine starting to count the 90 degrees from here, climbing to this point. So rotating counterclockwise. If we instead put the second ray right here on the negative x direction, then we can associate this point with the directed 180 degrees angle. And we count the angle like this, from 0 to 90 to 180. If we take the second ray to point in this direction, the negative y direction, the point that we associate with the angle is going to be this point, and the angle, the directed angle, is going to be 270 degrees. So counting from here, 270 degrees. What happens if we start counting the other way? What if I start counting clockwise instead of counterclockwise? Well, if we count clockwise, then we're counting negative numbers. So imagine here we start counting 1, 2, 3, 4, 5, 6, 7 up to 90. Here we're counting negative 1, negative 2, negative 3, negative 4 up to negative 90, which means that 270 degrees as a directed angle is the same thing as negative 90 degrees, because the points on the unit circle that correspond to 270 degrees and to negative 90 degrees are the same point. Similarly, 180 degrees and negative 180 degrees, which means we're counting in the opposite direction, they correspond to the same point here. And 90 degrees is the same thing as negative 270 degrees. Now, what happens if we complete the 4 right angles? So if we start, we count 90, 180, 270, and then we go right back to where we started, here. Then we complete the full 360 degree angle. This is the full 360 directed angle. It corresponds to this point here, which is a 0 degree point. Therefore, 0 degrees equals 360 degrees, because the point here on the unit circle is the same in the directed sense. So let's recap. A positive length segment is here. A positive length segment is here. A negative length segment is here. A negative length segment is here. A positive angle, so we start rotating like this, starting from the red and rotating counterclockwise, like that. We can even get to more than 360. We can get to 450 degrees if we just rotate 360 and then rotate 90 more. We can even get to negative 450 degrees if we rotate negatively 360, which is again the same as 0, and then rotate 90 more in the opposite direction. This amounts to negative 450 degrees. Find the largest negative directed angle on the unit circle such that it corresponds to the same point as 1000 degrees. And note that larger negative numbers have smaller absolute values. For example, negative 1 is larger than negative 100. Here's the solution. Let's draw a unit circle. First, we need to find a point that corresponds to 1000 degrees. 360, 720, 810, 900, 990, and here, somewhere here, should be 1000. And this angle here, because we reached 990, this should be 10 degrees. Which means that in the directed sense, this corresponds to this negative 80 degrees. It's negative because we travel clockwise, so this is a negative angle. Therefore, the answer is negative 80, because we need a negative angle and we need it to be the largest. Let's see why it's the largest. We can make another round like this, and then we arrive at negative 80 minus 360 degrees, but this is smaller than negative 80. No matter how many times we do this, go around the circle like this, the negative angles are going to go smaller and smaller and smaller. So negative 80 is the largest negative angle that exists, which corresponds to 1000 degrees.